Hey guys, welcome to my video on probability. So, probability is a pretty broad topic, so I tried to kind of break it down into its most basic components, just for the purpose of standardized testing. So, let me start with writing out this template for you guys, which is a great way to start off your probability problems. And don't worry, I'll read it out to you guys. I am fully aware of how bad my handwriting is. Total outcomes. So basically what I wrote here is when you're setting up probability problems, you want to try to first identify how many outcomes am I looking for. Most of the basically you can find this number out from the problem. But you also need to consider what are the total number of outcomes, like what are the total possible situations that I'm picking a particular situation from. So for example, the most famous example, rolling a dice. So a dice has 6 faces, right? So that means that there's 6 possible outcomes that corresponds to this number right here. And if I want to find the probability of rolling let's say 5, well, rolling a 5 is just one of the possible outcomes because there's only one 5 on the dice. The numbers are 1, 2, 3, 4, 5, and 6. And out of each of these 6 possible outcomes, there is one outcome in which you will roll a 5. So that's why the probability of rolling a 5, or basically any one of these numbers, is a 1 out of 6. And I use this template right over here to help me get to that probability. So one of the situations that you'll have to use that template for is something where there's going to be 2 events. So to show you what I mean, let's use a dice example again. And let's say we want to find the example of rolling a 5 and another 5. And let's keep it simple. Let's say we have 2 dice, and I want to find the probability of both dice being a 5. So what I'm going to do is I'm going to set up like 2 event boxes. So this is dice 1, and this is dice 2. So same thing. Rolling a 5 is 1 out of 6. Rolling a 5 is 1 out of 6. But in order to find the probability of doing it both one after the other, you'd have to multiply, and you would get 1 out of 36. So 1 out of 36 is the probability of both dices being a 5. And, I don't want you guys to just take my word for it. Like, I want to show you what I mean by that. So again, I'm going to use, actually let's switch to an easier example because I'm going to draw a tree and I don't want to have to draw too many branches. But this is basically the same example, except I'm going to use a coin this time. So I have 2 coins, and I want to find the probability of heads and the other coin also being a heads. So again, I set up my event boxes. This is coin 1. This is coin 2. And first one, second one. Heads is 1 out of 2 because a coin has 2 faces, and heads is one of them. The second one, same thing. I multiply them, I get 1 out of 4. But what I want to show you is how do I represent that in a tree diagram, because I always find that tree diagrams are really useful for visualizing why this multiplication rule works. So this is the first coin, that's a P, not what I was intending to write. This is coin 1, coin 2. So coin 1 can either be heads or tails. And from these rolls, the second toss can also be heads or tails. Again, heads or tails. So this means that our 4 options are heads, heads, heads tails, tails heads, and tails tails. And you can see that out of these 4 possibilities, only one of them is what we were looking for, which is the probability of both rows being heads. So that's why this multiplication rule worked. You can try it with our previous example, the dice one. You can, do all the 6 probabilities, and then you can make like branches for all of them. But, just take my word for it. It's 1 out of 36. You don't want to draw 36 branches. But that's just like a little mini proof on why this works. Here I have a word problem for you guys. Alright, let me read it out loud in case, again, you guys can't read my handwriting. So Tom has a jar full of marbles, and he's going to take out single marbles without replacement. In this jar, he's got 10 red marbles, 5 blue marbles, and 3 yellow marbles. So we want to find the probability of Tom drawing a red marble of Tom drawing a blue marble or a red marble. So let's work that out. He's got 10 red marbles, 5 blue marbles, and 3 yellow marbles. So in total, he's got 18 marbles. And the probability of him drawing a blue marble is, if you go back to our template on the very first page that I wrote, the number of desired outcomes over the number of total outcomes, the probability of getting a blue marble is 5 out of 18. For the same reason, the probability of getting a red marble is 10 out of 18. So what I'm going to do at this point is I'm going to add them, and I'm going to get 15 out of 18, and I'm going to say that the probability of getting a red or blue marble on his first draw is 15 out of 18. So why did I add this time and not multiply like I did for the previous example? Well, as you can see, we were looking for the probability of Tom finding a red or a blue marble. So or kind of means that our options are widened, If I come to your house and I say that I'm fine with apple juice or orange juice or grape juice, then that gives you multiple options for what you can serve me. So this means, because of this or, it means that both the probability of a blue marble or a red marble are valid in this situation, which is why we would add both of these probabilities to get a combined probability of 15 over 18. I have another problem for you guys. This is a follow-up to the beginning problem. So what is the probability that Tom will draw a blue marble followed by a yellow marble? So that's kind of like what we were doing in the beginning. We have 2 events, and we know that we're going to have to multiply them because we're not looking for a combined probability this time. We're looking for a blue marble, has to be a blue marble first, it has to be a yellow marble on the second one. So the probability of drawing a blue marble, like we discussed before, is 5 over 18. But here's the thing. As you can see in our previous example, the one with the coins and the dice, I had 2 dice, I had 2 coins. But this is the same exact bag. So this is what we call a dependent event. It's not independent like our other 2 multiplying examples. So in this dependent event, because Tom already drew a marble, his second draw, he's only going to have 17 marbles left to work with. And because of this, the probability of drawing a yellow marble is going to be 3 out of 17 instead of 3 out of 18. So this is something you guys need to be mindful of when you're solving these types of problems. You have to realize whether the events are independent or dependent. So just to finish solving this problem, the answer is going to be 15 out of, quick math, 18 times 17, that's 306, I believe. Yeah, 306. So that's the probability of Tom drawing a blue marble followed by a yellow marble. So that basically concludes my video on probability. I really hope it helped. Feel free to like, comment, and subscribe as always.